Hello, and thanks for joining. I'm Jonathan Wright, and today I'm going to be talking about performance lifecycle management. This will help you shift left earlier in the lifecycle to enable performance engineering by using your favorite tools to do continuous performance, and then also shifting right to enable continuous monitoring in your production environments and learning what your real users are. So, let me start with a little brief introduction of myself. I started performance testing back in the 90s using tools like Astra Load Test. I moved on to using the LoadRunner products, Performance Center, the Green Hat products, and then I moved on to using some of the tools and technologies that are open source, such as JMeter, which I'll be talking about today. At the moment, my role is Director of Product Management for a product called Agile Requirements Designer. I'm also a distinguished technology evangelist, so I spend a lot of time speaking at events similar to this one. So, to give you a bit of background on some of my skills and my experience, I've got a number of roles which I'll be talking about today where I've helped enable performance engineering. I've also been in the space where I've worked with companies like Microsoft, where I've helped enable things like WinOps, so the DevOps for Windows, and that's using their performance tools. I've also been involved heavily with Hewlett Packard, and I've helped with and shape their products to understand how to do performance engineering better. So that's including using their SV and NV products, and of course using the CA stack, most recently with BlazeMeter, and I'll be talking about Blaze API and also some of our other upcoming releases. From the thought leadership space, I've written a number of books around test automation, and most recently around digital experiences, which is understanding what your customers' personas are and understand how to pull that information left. Some of my colleagues, as you can see on the right hand side, include Joe, and most importantly Todd DiCaprio, who will also be doing a session today, who's also written a fantastic book which I highly recommend called Effective Performance Engineering. Episode 1. For those who've also subscribed to the Automation Guild, you'll recognize this format from my keynote. For those who haven't, I'm going to go through a number of the Star Wars movies that will represent certain stages in my development within the performance testing and engineering space. First, I want to just quickly run through some of those trends that Joe mentioned in his previous session and how I think they apply to performance engineering. So the fact that we talk about everyone being testers and everyone responsible for quality, I think as a role, as test in DevOps, which has kind of evolved from the software developer in test, looking at performance as one of those items as well as functional is important. So at every stage, you want to look at reuse and lean engineering principles such as service virtualization, network virtualization, and network function virtualization, and how you could potentially leverage them from a shift left perspective all the way to a shift right, which we'll be talking about today. So DevOps is also going to be very focused on measure and monitor, so understanding what good looks like and learning from those production environments, which I'm going to be talking about today with continuous monitoring and shift right. As far as some of those practices around BDD, TDD, and ATDD, you're going to start seeing those acceptance criteria, including things like non-functional requirements, which I'll cover briefly. I've also seen this move to open source strategy, which is really around what tools and technologies can you use, such as JMeter, and how you can leverage those. I'll also be giving you an exclusive around our LoadRunner to JMeter converter that we've recently launched, and how that might be able to help you start consuming the open source tools within your CD and CI continuous integration and continuous delivery pipeline. We're also seeing a number of different JavaScript frameworks. I think I've just mentioned JMeter as a great example, but what I'm going to be talking about also is Torus. So if you go to gettorus.org, you'll be able to see what kind of tools and technologies and frameworks you could potentially use to help do this. As far as visual validation testing, of course, you may look at UI components as far as your scaling. So in the old days, it was click and script, but you can combine these for more complex things such as wearables and testing applications which don't have any messaging layer. So some of the Citrix applications, I've done this in the past. One of the big things which I've just mentioned about, and I think is going to be really important, is visualization and containerization. I'm doing a lot around service virtualization at the moment, and as I mentioned about NFV and NV, those are both really important components when we're talking about lifecycle virtualization techniques and also containerization. The micro-containerization architecture is something that I'm working quite hard with our research and development team based out in Oxford, and that's really putting a microservice on the front of a container and making it smart. So the ability to maybe deploy things like unikernel architecture, which I'll go through later on, to scale up load injectors. This is something that's very resource intensive, and reducing the footprint can really help you scale with what do more with less. And talking of doing more with less, this is required when you start talking about things like IoT. I've also had experience of looking at scaling this to 10,000 end devices when I'm doing performance engineering techniques for things like virtual power stations, each of them having an SV component and a response on a REST, and I will go through an example later on. I mentioned again around the microservices architecture. This is something which we're seeing more and more, and requires more and more complexity around testing those landscapes. So understanding and being able to visualize the complexity is typically sat in an ops kind of space, but actually leveraging that technology to understand the dependencies also will help you from your performance engineering. And then the ShiftLeftRight aspect, where I talked about testing in production, is really this: how do I learn from what my users are doing and pull that information left? And also, what am I doing from a left-hand side that I could potentially reuse as far as upstream and downstream systems are concerned? Talking about autonomous vehicles, drones, this may be something that you won't be seeing on a performance side of things, but I can tell you from a visualization perspective, you will still have to test these platforms. Thus, even though the end device is just an IoT device or an endpoint, you'll still be able to need to understand how that's going to scale. Episode 2. In this chapter, I'm going to take you on the journey towards becoming a performance Jedi. When I started my performance testing career, applications were still client server. My first test of dealing with high volumes was when I was working in New Zealand for New Zealand lotteries. As you could probably expect, when their biggest ever rollover jackpot occurred, they needed to be able to deal with 26,000 connections. Now this was a huge amount, and the technology what was underlining it was Flex, which was really quite difficult to scale. Even though we had the best kit, we still had to performance test to make sure it was going to be able to deal with those kind of scales. So part of that was also being able to log the information on what was actually happening in production and use that using a kind of a reverse proxy to then give us the necessary kind of transactional throughput to replicate their previous biggest jackpot. So one of my challenges was trying to reach out to find myself a mentor and people that I could speak to within the performance testing community that would be able to help me on this challenge. Reaching out, I made a very good friend, Stuart Moncrief, who runs myloadtest.com. And the last time I spoke to Stuart in some detail about this, last year in Melbourne, he showed me some of these memes that he'd been working on, and part of some of the challenges he's found working for large-scale organizations in Australia around the performance space. His background is very much in the NV space, so he understands both hardware and software network virtualization, and he's a very talented performance engineer. Part of my journey was then looking at how I could mature my skills and wrap around some processes to help me on a maturity model around performance engineering. So what I'm going to share with you is a large-scale project that I ran over for the biggest ESAP implementation in Europe, and how I helped wrap around some quality processes to enable performance engineering. So first of all, one of my problems and one of my challenges that I had in this area was really understanding and relating this back to the business. As you could probably expect, when you start doing large projects like this, people want to understand and answer questions. They're not too worried about individual transactions and whether an individual transaction fails at a certain scale. They want to understand chains of dependencies and non-functional requirements so they can understand the risk profile behind it. So really correlating all of these components together provided a picture of the quality or the assurance that could wrap around and the confidence level of what we were doing. Each run that we did, we had specific aims to increase confidence and prove something. So prove a hypothesis that we were trying to understand that the business could then make a decision about. So I'm going to take this example, and I presented this at the British Computer Society about 5 years ago. I talked about a very high level business level question and how we want to understand or get an answer that makes sense to the business. And through this number of slides, I'm going to show you how I broke that down and able to answer that question in a clear, concise way. And also the dependencies of how one-to-many relationships between requirements and execution to prove a particular hypothesis. So in this particular question, we're trying to understand a role within the organization, an activity that role has to do, and some kind of expectation of how long it's going to take. Now, the usual response to this is we've run tests, we don't understand the tests, we have no direct correlation to it, or we have an answer which is everything seemed to work fine, and then when it comes into production, usually these are the challenges are there. So let me talk about the framework which I built for this particular use case. Now, one of the things I realized, one of the things I wasn't able to do was running a single tool wasn't going to be enough. So I was looking at creating a scheduling service that allowed me to control a number of different tools to actually run simultaneously. This was mainly because not only did I want to get a mixture of UI components and then protocol level load tests, I also wanted to be able to inject ambient noise and traffic, which required a number of different aspects. First of all, it required kicking off interfaces, of which there were 700 interfaces. Some of those interfaces, as you could probably expect, needed to use service virtualization or did a shim and stub to actually allow it to be able to create the necessary, say for instance, IDOCs. And also we needed to artificially inject load onto the CPUs and cores, and also utilize certain amounts of the memory and network utilization and disk locking and database locking to make it more realistic. Now this is an approach which I've spoken to people like Scott Barber about in the past, who's more traditionalist when it comes to looking at load and performance testing. This really was around building confidence that it's not only injecting into the application and or solution the test, it's also providing a more realistic view of execution. And this is why within performance engineering you're looking at different types of sessions or tests, and those can also be blended together with different profiles. So in my case I was talking about user profiles, which are people or activities that are happening on a number of different systems, of which typically there's around 26 to 30 components within SAP. Also controlling things like the batch, so being able to kick off jobs that need to happen, and then things like the background aspect, so interface traffic, copying files between locations to put load on the network, using not network function virtualization, using network virtualization and service virtualization to really create some more realism. And part of this is the scale. So how do I trace all this back? I talked about non-functional requirements and how they're really the center, but we need to understand and relate all of these components together so that when we understand a individual transaction, so we can understand the relationship between a number of transactions, which could be a test, and then a number of tests that could potentially be a scenario, and then a model of those many scenarios, which I will show through, against some kind of design. So typically in this case, there was a number of, well, there's about 2,000 process design documents, which we had to understand the non-functional requirements of each one of those individual components. And then we needed to be able to create or architect sessions that would be prove this with those various different profiles. So those user, batch, and background noises. So part of it was a huge complexity around this, and this was a kind of a unique approach that really allowed us to provide traceability to kind of the overall business project risk and technical risks, also to the domain, to the business, so they could understand the business side of things, and also the domain in the language that they understood. So as you'd probably expect, being in the SAP community, you really need to be able to understand things like SAPs and how those correlate, and how they correlate back. So part of this diagram, which I've just kind of shown, is understanding how a session, so that's that load, stress, soak, benchmark, whatever your activity you're doing at a high level, or even if you're trying to rerun things from a test optimization perspective with a number of different profiles associated with that user, batch, and background, and then within each one of those scenarios and tests and traffic or transactional flow under each one of those components. And as you can see on the right hand side, it's an end-to-end relationship between those design documents, the non-functional requirements, the interfaces, and each one of those components. You probably, if you've dealt with any kind of enterprise test level of load testing or performance engineer, you'd understand the significance of having more realistic flows. So a bit of an example here, obviously I've grayed out some of this so it's not specific, but you can see some of the interfaces that we looked at having to target from a performance engineering perspective. Last week I spoke to the biggest ESAP customer on the planet, and this organization, well-known organization, runs the biggest app store on the planet, and each transaction that you do on that particular store is an ESAP transaction. So they're obviously dealing with millions of transactions per day, and part of the challenge they had was dealing with the ETL side of things of Teradata and dealing with large scale big data, and part of that was their machine learning platform which they're building, and understanding what's trending. The quicker they can get that information obviously is very valuable for them, as you know, that's one of their main revenue streams, as well as being a mobile device and laptop manufacturer. So part of it is the large scale organizations are also dealing with this huge complexity, and part of that is understanding hundreds if not thousands of these transactions. And it's when you start chaining these together and you move one level above, so from individual clusters of transactions, which could potentially be interface, noise, ambient transactions, IDOCs, whatever that might be, plus that user load, you start representing functional components, and I think this is where typically your SAP consultants will come in and understand the different flows and business processes and the dependencies of those, and how to chain them together, and be able to visualize that and see in this particular case, green being meeting the requirements, and then if one component starts causing problems in that particular area, the dependency of that of an overall business change, because part of that is that individual transaction might fail, but if the chain of transactions is acceptable for a response time, and that could be a web store, for instance, and that store what might be implementing something like click and collect or buy online and pick up in store. Part of that is a number of different transactions that may be going between warehousing, point of sale, their front end, app or the mobile app which they're doing to pick up that item or reserve that item. There's a chain of activity that goes on there, and as long as that transaction's within an acceptable time, obviously if you look at the standard industry of saying after 3.4 seconds they're going to navigate away, I think you'll see that typically that's changed to it's if they can't find the information that they're expecting within that kind of time frame and getting the response that they're expecting and it's rendering correctly, and there's a lot more other aspects to a digital experience. That digital experience might even be Alexa or some kind of virtual personal assistant. There's a whole stack of chains now that consume this. It's not just a single UI device. It could be a car, it could be a drone, it could be a virtual power station. There's a lot of activities upstream and downstream which you have to now take into consideration. And so kind of where we move on to is, how do I answer that question which we started off on? How do we deal with it? And that could be a number of non-functional requirements, a number of different profiles that we need to look at, interfaces and batch transactions, as well as a particular session which you're having to run. So a baseline verification, a soak, might be an 8-hour looking at a certain component which might have a certain profile of a user activity, which might be the month end or quarter end, and a similar kind of background profile. And then there might be a number of business processes that are chained together with APIs and interfaces and IDOCs that all need to happen as part of that scenario. So that could be individual blocks. So A1 goes to B2, and a bit like with the Agile Requirements Designer tool, which I am responsible for, is how you model those paths through the application and those edge and what data you're using. So that could be a particular work stream variation where the workflow is different. It could be a different language. It could be a different location with workflow behind that, and then an individual test which is actually going to run to prove that. So there's a cascading effect of this information, and then only at that point in time when you're actually the measurement is request that particular credit score, and then you're seeing at the worst case scenario, which is 100 users, and at month end or quarter end, that you're going to get that response, that 95 percentile of those reports coming back in there. So there's so much complexity there, and I think this is what's challenging in the performance engineering space. So being able to start building up those individual transactions or those business process tests and scenarios earlier in the life cycle is absolutely essential, because there's going to be a one to many relationship which you need to start being able to understand the dependencies on. And kind of where I kind of move into this final kind of analysis, and I think this is kind of the opposite side of things. A lot of around performance has just been about the testing aspect, not really the tuning. Something fails, or is it, how do I deal with predictive growth of load over time? Is this going to be performant based on the data size increase or the traffic increase based on the prediction of 30% growth of new customers? So there's a whole stack of extra scenarios that you need to do based on the volumetrics of these side of things. It's not just under that one scenario everything's going to be fine. That's really where it's just a test compared to really the engineering side of things of growth. So part of it is, like we said, is modeling the transactions and the business flows and understanding those components, but also understanding the right level of scale. So there's an item there in the corner which kind of says, well, the non-functional requirements that it's got to be, that order crate's got to be back in 3 seconds or something, that transaction, that individual transaction, pressing the button. But then we've got kind of weightings of understanding, well, okay, well, what's acceptable? Maybe that's 5 seconds. But then in different environments with different service virtualization components and throttling, and then maybe you're dealing with from the ESAP perspective, you're having to ramp down the amount of cores. The SAP score isn't as high. The amount of synthetic or subset of data is not at the same level. It's the caching is not there. So you have to start taking these into consideration with what a lesser strong environment than production. Mimicking production now is incredibly complex for a like-to-like basis. So then you end up kind of getting some kind of what I would class a performance index, where you can kind of say, well, actually, based on various different components, hardware, software, configuration, and everything else, is actually 4 seconds is actually acceptable within that environment. So part of it is there's a definite art to this kind of skill, and part of it takes a lot of skilled resources that understand performance engineering and not just the software side of things. They need to understand traffic, network, the load balancing, the different individual hardware, what's going to be configured. So there's so much. It's such a black art, and don't get me wrong, I'm not trying to put people off. I think every step is proving something which adds value, but there is a bigger picture to this, and part of it is also being able to articulate that back to the organization. So we showed at the start with Dilbert kind of just coming back saying he's not quite sure if the test passed or failed or what it did, but he's able to come back and give the edge case, which is worst case scenario is every single credit manager in the organization, probably that plus the organizational growth, all requesting at the worst peak time, they'd all still come back within that time frame. And I think that's the whole point, is you're proving a hypothesis, but you've also got to be incredibly clear of how you actually support that argument and understand the dependencies of that. And like I said, part of that confidence is building a particular scenario that proves a number of these business level questions, not just a single run for 8 hours proves this one scenario. You're proving lots of separate problem statements, and that you've got to add value. At what point it becomes diminishing returns, that's when you think about stopping. Once you've got a confidence across enough of those components that you're happy with the level of risk, then you can and then only can you really proceed going forwards. So kind of this was kind of a bit of a snapshot of probably about 5 years ago when I did kind of performance engineering on the biggest ESAP implementation in Europe. But after speaking to the biggest ESAP user a couple of days ago, these challenges are even bigger now with big data and machine learning. These things are even more complex and a lot more unknowns. So part of what I put in the book was these approaches, which I've kind of demonstrated over the last few slides, they continuously evolve. So your approach and how you look at attacking this is still going to be incredibly valuable, and also what you learn from the PerformanceGuild from the other speakers is really going to evolve your thinking and your approach. There's no one approach to rule them all, or one tool to rule them all. Really, you've got to understand and evolve your thinking as you go along. Episode 3. Before turning to the dark side, I took some of the skills that I'd learned on the previous chapters and looked at performance testing as a service in the cloud. Partly what I've been talking about since 2010 is how you can scale up to do cloud-based, high-volume, automated or performance testing in the cloud. And this could be on Azure or Google. I'd won a Google Innovation Award, and part of what I was trying to do as taking it a step further is taking some of the practices and principles that I'd learned from doing on-premise performance engineering and look at how I could potentially scale this as far as geo-based to start creating more realistic load patterns. So some of the challenges that I'm going to talk about are at a much higher scale. At the end of this period of time, I was doing performance testing, as you can see from the shot here, whilst walking through the park, monitoring my load patterns and trying to get some real flexibility around doing this in and day out. As you can see here, this is Visual Studio running on a remote machine, but I started taking advantage of the load agents in Azure and how I could potentially scale up and scale down, plus combining this with real end devices such as mobile devices from Perfecto. So part of this architecture was really understanding what different separate components did I need to scale this kind of technology, including virtualization and service virtualization in the cloud. So part of it was a lot more challenges, a lot more understanding of the architecture around platform as a service and infrastructure as a service, and understanding some of the tools and techniques associated with that, and how you can leverage them to you set up and configure desired configuration state for instance, load testing purposes. So taking those practices that I talked about previously and looking at moving them and spinning up the necessary machines and infrastructure and configure that with the necessary ports that could be open, creating golden images which of say for instance Azure images, which I could then modify, open the necessary components, load the necessary items on there, and really just get a better understanding of how I could potentially scale what I'd done on premise into a cloud environment. Now, the great thing about this was really trying to look at how we could do this from a continuous testing point of view. So how we could actually kick off these tasks, remotely. In the case of the shot there, the same interface is being displayed on this in the browser as it is on the mobile device, but actually being able to run some of this, like this dry run load test, straight from something like TFS or Visual Studio Team Services online. So part of it was this change in how we could actually execute these tests, maybe on check-in, for instance, as part of your continuous integration, continuous deployment. But part of this, as I kind of said before, is a whole stack of individual components that needed to be configured and set up first. So that could include things like traffic proxies, load agents. You saw some of the interface stuff before, taking some of that logging from dynamic data adapters, so IntelliSense or IntelliTrace, to give you understanding of a stack trace information coming from things like SharePoint, if it was an application that was built in SharePoint, as you can see the MVC app in the corner, and also how you can potentially look at capturing that information and what you can do with that. So, part of this was setting up, some fundamental foundations to how you could potentially do the same kind of testing as you would do on-premise, but now in a cloud environment. So part of that was the whole tool estate. So as you can see in the bottom right hand corner, there's a number of well-known tools, including BlazeMeter, the Green Hat product, which I mentioned before, HP, LoadRunner, and Performance Center and StormRunner, and then things like other tools like JMeter in the open source community. And part of this was combining those as part of this DevOps tool chain, which was an essential part of everyday use. The Force Awakens. This will be the bridge between Rogue One, which represents the shift left, and the latest movie in the series, The Last Jedi, which represents the shift right. So part of it was setting the scene, and part of this scene was around this whole new complexity with digital engineering. So how do you deal with managing platforms like this one that I was involved with, which does predictive crime, when you're talking about including IoT combined with machine learning, predictive analytics, and a whole set of sensor data, video feeds, and other real-world environments. At this kind of scale, you need to not only understand that the visualization is correct, but also understand the different data feeds and how they can respond to react with the real world. One of the projects which I was involved with, which needed to have huge amount of load capability at launch, was the Copenhagen Smart City application. I'm speaking in Copenhagen next month around machine learning and AI, and we'll be talking about some of the smart city challenges that we had. Now, the first challenge was the expectation around 36,000 end users. Now, this 36,000 end users needed to be able to scale on launch. So when launching this application, which helped you calculate your carbon emissions by your journey to and from work, and included gamification, as you can see on the right hand side, for your employer to compete against other companies in the area. So part of this was not only seeing consuming a huge amount of GPX data, but also a big data store, which was a smart city data exchange, which was a big data platform in the cloud. So how did we go about doing this? Now it's an interesting approach because, as you would expect, this application, or this smart city application, was first of a kind, which meant that we didn't have any reference data. Therefore, we had to use one of our products, Test Data Maker, to actually generate 36,000 historical transactions so that we could run those through a single day. So we needed some deltas to be able to use as reference. At this point, I looked at doing two potential solutions. Solution A was to commission a group of people to actually go off and do various different journeys on bikes, and then this followed shortly with looking at leveraging enterprise crowd testing, or in this case, handing this off to a whole stack of university students at Copenhagen to walk around with their mobile device and a GPX logger to log information. They would then push those logs, and we would then look at taking the deltas and then synthetically generating routes based on modeling out the various different multimodal transportation, so trains, buses, tubes, various different patterns that we saw. At this point, this allowed us to create realistic speeds of people walking around, taking multiple different transportation routes, and then using the application. At this point, we thought it'd be useful to not only generate 36,000 virtual endpoints, but actually look at creating mobile devices, real mobile devices, to also deploy the application to and test on. Now, the reason we did this is we wanted to look at the battery drain and more realistic usage information, which was useful because actually we had to change the frequency of how we logged the GPX data based on the feedback. So this is capturing device information like CPU and battery drain, as well as the general performance of the end device. Here's an example of what we actually did as far as using, in this case, mobile cloud and Eclipse using Perfecto Mobile. And what we did is we looked at uploading the reference data, as you can see on the right hand side, where we uploaded data to the city data exchange, and that data then reference data was then used, as you can see on the bottom left hand corner, to provide GPX locations on a second by second area, and then it would power the various different devices, which you can see on the right hand side, to actually move around the city and then post their data and results up to the application to get a recommendation of the best and most efficient route to work. So this is it actually running on real devices. Now this is fairly short, but it will give you a kind of a taster for how we're actually moving these applications, moving the application on each one of those physical endpoints. What's important is when we did our run, our user blend, so this was real users, i.e. phones, was combined with the interfaces of emulating those mobile devices to make that realistic. So there was real devices combined with emulators that were in the cloud. So part of this new challenge was around digital engineering, around dealing with incredibly complex, large-scale smart city projects, machine learning, and some of the new challenges which we're seeing in the industry with fintechs and beyond. So this is a new challenge, but yet a new opportunity for performance engineering. As mentioned before, we're looking at the shift left representing Rogue One and the shift right representing The Last Jedi, to have a look at two separate use cases: how to bring your performance engineering earlier into the life cycle, and also how, from an ops perspective, how to learn from operations to then pull that information and validate what you've tried to prove on the left hand side, but also to take the real usage patterns and learn from them. So let's just have a look at the performance lifecycle. I mentioned about shifting left and getting closer to the problem. Now, as far I did an article in a book around something called design ops, which the analysts are calling BizOps, or business operations, which is taking DevOps further down the pipe. So not just starting at the development side of things, but really looking at the idealization sections about how quickly can you prove a hypothesis of an idea. So part of this is really some of this kind of lean UX, rapid prototyping, fail fast, learn rapid area, where we're starting to see, especially in the fintechs. And one of the examples will give you an example of a fintech organization that wants to be able to do testing very quickly. So taking that left-hand side where there's potentially some kind of value stream mapping of a number of different development pipes or potential projects that are making a change. So the example I got from last week with one of the customers is buy online, pick up in store. Now this could be across a number of different applications, the web app, the web store, the point of sales, as well as warehousing, all needing changes. But the value is to the business is the ability to sell online and give more flexibility to their end users. So value coming in from a left-hand side, which then really needs to be proved out from a shift left perspective. So this is how do I do the logic, create the code, and quickly test it. So this is security testing. So using something like Vericode, so you can do it straight within the code commit, doing performance testing or load testing quickly using something like JMeter or Torus, and then other options like unit testing and potentially using stubs and shims, service virtualization to prove this stuff out very quickly, very rapidly. And then there's the opposite side of the thing where we're looking at, well, real users, real business users that are consuming this application. Now, for a new idea like buy online and pick up in store, that's not in the real world yet. So therefore, you don't have the reference information. However, when you've got real users, you can, once you've deployed that application, you can validate that what you tried to prove out on the left-hand side is now represented by real usage patterns. So once the application has been deployed, you'll have a whole stack of reference information around, your load profiles, which you can then take from the right-hand side and learn to the left. So a lot of it is learning and monitoring and continuously monitoring throughout the application. So part of this is using tools like application performance management to actually then not only look at monitoring operations, but looking at monitoring testing and also in the development environments or pre-prod as well, for where you may be doing performance testing. The great thing about using these APM tools there, not only have you got the stack information that's available, but you can also get a better view of exactly what's happened. So if you start combining things like exploratory testing with automation, you can start understanding the kind of execution that's happened or the amount of testing that's happened in that particular environment. And you can also start learning from that. So you can actually take that and use that as patterns based on, say, for instance, exploratory runs through the application or transactions that have been manually kicked off. This is the manumation approach, the manual effort to generate automated reusable artifacts. So this is really very useful, and I will talk about this later on. But part of this is the quick feedback on what we would normally traditionally call customer experience, or in this case, I've moved to calling digital experience, which means potentially your end customer may not be a human. This person might be a car or a power station or a train or a bot or some kind of M2M, machine-to-machine interface. Therefore, you're not always getting feedback from customers, and also user interfaces may not exist, especially when you're talking about Internet of Things and Internet of Everything. So part of it, you see some of the key traits that go around innovation, intelligence, assessment, insight, learning, support, delivery, testing, improvement, operations. And these are all continuously iterative activities that are not restricted to a single component. Therefore, when an application is deployed into production, that's not where it goes to die. You have to be continuously evolving. Therefore, you need to be learning and measuring and monitoring. So the hypothesis that you originally, or the idea that you originally came up with, is still proven, even though it could be 6 to 12 months down the line. It's not just we've performance tested it once. We're not going to make sure that it's dealing with the year-on-year growth of the application of the business. So this kind of goes into this whole flow. And part of it is I kind of wanted to go backwards a little bit for a second to give you an idea of how you'd look at this from an operations perspective, so the shift right aspect. So part of what we're seeing with ops tools, and to me DevOps, when you talk to people like Dan North, is all about blurring the boundaries between dev and operations. So what you're seeing is those developers, testers, and even business are starting to use those operational tools. And part of that is to get a bit of understanding and measure and understand what the application is doing and how it's performing. So it's that quick feedback loop, but it's also using different tools. And part of what I did a whole article around, which is called Legacy is Your Legacy, which I'll put up later on. Everything's just a node. So once you learn from those individual nodes and then flows through those nodes, then you can get a better understanding of how things are interacting, or even what functionality is being used from an end customer's perspective, and then also the revenue that's generated associated there. Very goal driven. So a number of nodes get hit. There's a positive or negative experience that comes out of the back. There's also data associated with those nodes that flows through, which you can also capture. This is a very typical, using something like Fiddler and reverse proxy, you can quite easily capture what data and what information is flowing through, say for instance, an app server on port 80. And part of this is turning on those probes to actually be able to get as much information as you possibly can. Now that could all be all the way down to the network level, or even levels below if you're using things like Wireshark. But really it's about capturing as much information throughout the life cycle as possible. And this is one of the bases for our tests, to be able to test those individual nodes, whether that's talking about penetration testing or security or another kind of testing. Part of it is a lot of reuse. So part of this ops area that we've been dealing with, and we used to previously call deployment, or have a deployment tool, is all around how you deploy to that environment. This is now taken for granted when you're looking at the DevOps big picture, but really this configuration and deploy is as important as it would be on the left-hand side. So this is configuration as code, automation as code, pretty much anything as code. So part of it is, what are we trying to do? Well, we're trying to spin up the performance, the platform and infrastructure. And as part of that, you may go into things like system integration test. So this is where we potentially remove some of those constraints with virtual services, your middleware, and your back-end systems, and use tools like VTDM, so database virtualization, to actually use the kind of the Netflix of database, so you don't have to keep on burning that subset or mass test data that you've got. You can also connect it into your systems. It still thinks it's an actual full-sized image instead of having to do the whole copying. And this is kind of important when you're talking about performance engineering, because you burn a whole stack of data, especially on an 8-hour soak. So your ability to restore that data instantaneously is really important. So database virtualization is a big component for this. And then on the left-hand side, part of this whole integrity is then moving into a model. So understand the model between each one of those nodes then gives you the flexibility to virtualize those nodes, but also understand the dependencies of and how the data would flow through those components. The ability to abstract that over the code, so keep the requirement model or requirement test and code in a triangle and not break away from that, allows you to understand the code that's actually being executed from, say for instance, IntelliTrace is being exercised by a particular test and is also linked to a particular requirement. And you can also then tell who wrote the code, who broke the test, whatever it may be. So keeping that triangle intact is very important, and a model is a good way of keeping those three components. And then of course you've got your SonarQubes and your static code analysis tools and all those other kind of areas that give you a whole stack of useful information. And then on the left hand side, there's three different ways to look at this. There's the model-driven delivery kind of development kind of world, where you're using models, business process model notation, XPDL, extendable process definition language, or you've got your TDD, BDD, ATDD, executable specifications that most of the time are just text files that you've got to manage. And then you've got your traditional requirements, which may have functional and non-functional requirements associated with them. And you've got to manage this against user stories or tests or requirements, whatever you need to do. So there's a whole stack of dependencies between each one of these components. So part of what I was saying about the whole ops and test side of things is what you're seeing in the middle is typically those items that testers touch are now across a number of different areas. They're sat in the operations side of things, and the monitoring tools, as well as they're doing the continuous integration, delivering value into your CD/CI kind of landscape, you're also involved in your agile engineering area of shifting left and getting testing earlier, which was kind of some of the software development in test or the test in DevOps kind of area. And really, there's only a few boundaries that you don't really step into. So, maybe some of the good coding practices or decoupling service-oriented architectures, or potentially some really heavy ops stuff. Typically now our reach has really increased, and with this reach has given us the ability to start leveraging these ARA, the automated release automation, application release automation tools, the APM tools, the service virtualization, network function virtualization tools. Suddenly we've got a whole stack of lean engineering and reuse. As I mentioned before, I did an interesting blog around legacy is your legacy, and part of that was saying that everything's a node, but once you can understand the metadata and meta mathematics that sits over the top of it, you can understand the dependency of and the flow of that, which really helps, as you saw on the previous one, to really model out those applications, but also to understand where the data flows downstream and upstream. Typically, you'd find on average there's around 30 upstream and downstream systems that are connected to each other, and understanding the flow of these upstream and downstream systems allow a lot of reuse. So this is where potentially stuff that you generate out of the back of your system would then potentially be able to be leveraged by another team who may or may not be as far down the development chain. So understanding your I'm going to say legacy for a second, but understanding your core IT is essential to be able to understand the complexity around your ecosystem of ecosystems, where the sooner you get to understand the data, the more you can do with it from a kind of a data science perspective. Rogue One. This represents the shift left. This is a trend we're seeing in the industry, where rogue developers, or dev anarchy as my good friend Dave Fox would say, are utilizing open source tools and technologies to help them rapidly generate prototypes and prove the applications under test. Within this chapter, I'm going to explore some of the open source strategy tools, starting with Taurus. As I mentioned before, this is an open source execution engine which enables you to quickly create and develop JMeter scripts or execute JMeter scripts. This can be run on Windows, Mac OS, Ubuntu, or even you could run it from a Docker image. In this example, I'm going to show you how to pull a Docker image down and run your first test in Taurus. So within Docker, you pull the latest repository, which will then start up that instance. In this case, what I'm going to do is I'm going to look at a simple YAML script, the same simple YAML script you can find if you navigate quickly to the home page, scroll down, and you can see here's a simple test running 100 concurrency, ramping up for a minute, and then holding for 5 minutes. So what you can do is you just can copy that script and point that at your application under test or some kind of endpoint. I'm also going to show our container management tool to show that I'm running my development application which I've deployed into another container. This is just a simple web store and can be launched a simple UI. So what I've done is I passed the local IP address of that, which is the container, and I've just done a very simple test to run 8 script concurrency against it. So all I'm doing is I'm pointing it at that simple YAML script, executing it, and then as you can see, JMeter will kick off and run a few scripts under that particular Taurus instance, as you can see. So it's going to run, and then what we'll see is it'll stop in a second once those tests have finished executing and the results have come back. So quickly come back in here, and we should see that Docker container is gone and the tests have successfully run against the web store. So that's as simple as just creating a simple YAML script pointing to an endpoint. Of course, you now have a number of different options. You could either run that as part of your CI/CD solution at a command line interface for testing, Or you could include the /cloud command, which would then launch that test to run on BlazeMeter and then in high volumes. So you've got flexibility of both on-premise, locally running on your dev machine, or running as part of a CI/CD process. One of the reasons I wanted to introduce this is what we're seeing is a move towards micro-containerization. So I mentioned this earlier around putting a simple microservice at the front of your container, but what I wanted to extend this into is around potentially scaling this to be able to represent hundreds of endpoints. And this is where you could potentially use things like service virtualization to replicate an endpoint in some kind of microservice architecture which you want to virtualize. So first of the big challenge is typically a standard container, like the one that I just pulled down, is quite heavy. You know, it'll use about 128 meg, 1 gig container, quite bulky. Now, if you move this and deploy it to a unikernel container, so something running like Mirage OS or Alpine, what you can do is you can move the host OS outside, so that way you can reduce the footprint considerably. So 16 megabytes of RAM, 88 meg of disk space is much more linear. So you can then run something like Taurus as the pure execution engine, or you could potentially look at using Selenium in a headless mode if you want to combine it with a bit of UI, or whatever else you'd like to deploy in that, as far as maybe an SV agent to replicate an endpoint. You know, it's a much smaller footprint. Now, I've scaled this kind of architecture to hundreds of containers on UCPs, so Universal Compute Platforms. And one of the examples that I did was to be able to run and scale up 10,000 endpoints to be able to test a virtual power station. So part of that challenge was each one of those endpoints would have a unique throughput of demand and response amount of energy. So you'd send a request to spin up a wind turbine. Depending on how much wind was generated, the energy footprint would be unique. So part of taking that data as part of the virtual power station, it would then be able to, in a 5-minute period, would be able to buy and sell on a commodity platform the electricity that's getting generated, also using things like predictive weather to understand what it's expecting as far as maybe sunshine on one of those solar panels. So part of it is you need to uniquely identify those endpoints and be able to scale into huge amounts, and also emulate those different types of IoT devices, or be able to scale up load injection to have thousands or hundreds of thousands of load agents running. So there's a lot of opportunity here to really take advantage of this technology. Equally, from a Windows platform, this is again back to the WinOps kind of storyline. As of Windows 2016, you've now got native Docker, so that's on top of the standard Windows containerization that you get. So therefore, you can this technology is enabled by default. So what you saw, what I just executed, you could run on a Windows server, giving you either more flexibility within a Microsoft stack or Azure stack on-prem when it comes along. You may be saying at this point in time, well, that's all fine and good, but we've invested huge amounts of money on kind of building traditional performance tests, and of course you want to reuse those artifacts. So this is an example of a load runner script that I did for the lotteries, and as you can see, part of it is a number of different individual transactions which I'd created, buying a particular ticket or confirming a particular purchase, and what I want to do is I'd want to reuse those components and convert them. Now, when I first spoke to Alon, who was the founder of BlazeMeter and one of the biggest contributors to JMeter, I talked to him about this idea of doing the JMeter to the load runner to JMeter converter, and I mentioned, I know some of my good friend Stuart Moncrief had been involved in doing something very similar, and also looking at understanding the quality of those load runner scripts that you've generated. Now this, as you'd probably expect, you can do a similar kind of thing when it comes to the Microsoft load testing tool as well. But let's just give an example with the script conversion that's now available at shiftleft.blazemeter.com. So this is using JMeter 3.2. And what I've done is I've zipped up my HTTP directory, and what I'm going to do is I'm going to drag and drop that into the script converter. So what this is going to do is, as you can probably expect, it's going to convert that HTTP into JMeter scripts. Now, if I had TrueClient, I could also convert those to Selenium. So I talked about click and script earlier, but TrueClient and things like StormRunner is kind of obviously a very powerful capability, and you may have also invested in that. And as you can see out the back of that, it's told you the percentage of the script which is being converted, and also some unsupported functions. Now we can see here what web concurrent start is an unsupported function within JMeter. Now obviously we know that's a load runner function that enables multiple HTTPs to start at the same time. So partly what we're doing here is we're going to have to find a alternative capability within JMeter, or if it's not important as far as that capability is not necessary to prove that script out, then we can just remove that out of the overall JMeter script. So what we're going to do is we're going to download these converted scripts, and what it's going to do is it's going to send back a zipped file. And what we're going to do is we're going to take that zip file, and we're going to have a little we're going to take out the components that we need so that I can open it up in the JMeter application. So first of all, you can see on the right hand side that it's created a preview of the converted load runner to JMeter, ready to be run in something like Taurus. So this is a standard YAML wrapper in the similar structure as what we saw on the previous demo. In this case, it's for Facebook, as you can see by the URL. What I'm going to do is I'm going to download that zip, which is going to contain everything that I need to be able to run this script in JMeter. And what I'm going to do is open that up, and what you'll see here is there's a folder structure, which I'm going to go to the JMeter or Selenium script subfolder, which will contain the JMX file that I'll need to be able to run. So as you can see in here, I'm just going to expand this out. You can see the YAML files in there, but also what I really want in here is the request.jmx. So what I'm going to do is I'm going to pick that file up, and I'm just going to drop that into my documents folder, and then I'm going to open up JMeter. Now, for those guys who are not familiar with JMeter, I highly recommend that you look at some of the training available online. There's a lot of material out there within the community. Obviously, it's very widely used in a kind of a CI/CD kind of manner, especially for your most popular kind of Jenkins stacks and stuff like that. So I'm just going to open up JMeter now, and just go to File and open that requests file that I just downloaded. So if I just go to that, and click open. So what we're going to see here is now you've got the overall structure of everything that you need to actually be able to run this and execute this script right now. So your cache files, your cookies, everything else, you can change the loop counter. So it's all ready to go and execute in that state. So that just kind of gives you an example of going from a load runner script and converting it into JMeter, and now being ready to execute JMeter in your JUnit kind of command. The Last Jedi. This new exciting chapter kind of gives us a glimpse into the future and what we can start expecting to see, especially within performance engineering in the next few years. So first of all, I wanted to kind of set a bit of scene with a chapter that I recently did around digital experiences. I think I mentioned this earlier on in the chapters around how looking at the different personas and different engagement models from a digital perspective. So that could be IoT in those kind of smart city, your car to X, infrastructure to X, talking to the traffic lights, talking to different other cars that are sat around there. It's your virtual personal assistant that joins you in the car and is able to take you on that journey to different locations, updating your calendar and understanding, when meetings change, which route it needs to recalculate to, books you your your parking spot, allocates diary updates, has conversations with other bots. Part of those digital to digital experiences is a whole M2M, machine to machine, IoT, Internet of Things, Internet of Everything kind of landscape of all this stuff coming together. And I think within each one of us that are on this who joined us today is, it probably fits in one of these categories, whether that's a digital native, somebody who's been kind of born into that from a Generation X point of view, whether it's somebody who's digitally dangerous, which I know a few people who are in this kind of space, who are kind of bordering on being a hacker, could potentially cause damage because they're able to are able to do kind of things they shouldn't be able to do with the system. So the big part of the book is that there is no UXs that I talk about. So the entire chapter implies that you're using a UI, but in actual fact you're consuming the microservices or API or bot to bot or M2M aspect. And this is interesting because how we consume this technology at the moment is very much seen as an app, mobile apps and UIs for browsers. So I definitely recommend having a read of the book to give you an idea of what the future's coming along, and also kind of get an idea of some of the challenges that will be associated with that. So I'm going to rewind to about 5 years ago when I spoke at an event for Gartner, and that event for Gartner was around lifecycle virtualization. And at the time I was working for a large investment bank, and I said that within that investment bank, I was responsible for 2,600 applications, 14,000 endpoints, and just over 4.3 petabytes of testing data in the landscape. And part of that was extremely challenging. I mentioned about upstream and downstream technologies, and part of it is that dependency of a single physical endpoint could potentially have up to 30 upstream or downstream or even more kind of ecosystems of ecosystems. So the dependency gets incredibly complex, and each one of these has its own messaging bus, APIs, service-oriented architectures, databases, or big data. You've got a huge stack of complexity, load balancing, and all we see is a front end. Obviously, as a performance engineer, you're very aware of these application landscapes, especially with the model view controller kind of view of the world. But then the dependencies of those upstream and downstream systems are huge, whether or not that's your PayPal, your third parties, whatever else the social side of things and how that clicks in. So part of when we talk about multi-layer testing, we're talking about the combining things like UI testing and some of the techniques you might have learned from my session before around the UI automation space, but also that kind of also delved into API testing. And if I'd have had a bit more time, I would have probably talked a little bit about Blaze API, which is a new product that we've just launched, which gives you the capability to run APIs at scale, and does that kind of testing and modeling based on taking some kind of spec such as a Swagger 2.spec or something like that, and then it will generate all the tests that you need, the API tests you need to run. And you could combine those into your load test. You could combine those messaging aspects, those MQ messages, you could inject those. You can do the interfaces like we talked about with the ESAP landscape. We've talked about databases and how you can use database virtualization, and also you can lock those databases. You can inject data into them. You can throttle them, each component. So part of that, what we're discussing here, is all about lean engineering and reuse. And so the reason why I was trying to set the scene is to kind of say, well, okay, where do we see things going? And also to kind of say, well, there's the whole shift left and shift right aspect. from what we've talked about, this shift right aspect is the real, the user interaction, the kind of the reverse chaos monkey, the reverse proxy kind of view of, well, these things are already happening. How do I capture them and then potentially model those interactions that are happening on the left hand side? So kind of to set that starting is how do you capture and probe all those components? And I mentioned it slightly before, right? Those four concepts around learning what those nodes were doing, the understanding the data which those nodes were consuming, and then probing them from a stack perspective all the way down to the network. And you can't see the network; it's slightly hidden behind me. But now we've got a whole stack of information where we can understand whether those operational tools, infrastructure management tools, environment management tools in each one of these environments. So we can capture a lot of information. So what I'm going to show you is a demo that I gave the analysts when they came over to Santa Clara in Silicon Valley, and we sat down and I kind of said to him, okay, well, shift left's great, but from a shift right perspective, how do I take real usage patterns from the right hand side and in the ops world and pull those back in and model those and create tests out of the back of them? So part of this was kind of an early kind of example of how this is possible using one of our platforms called it's digital experience analytics. So this platform is actually based on our machine learning platform, Jarvis. So actually it's got machine learning embedded into that to kind of predict what the users are going to do. But what I was interested to do was deploying an application into somewhere like AWS and then having a fresh operational portal to see what those users were doing. And in this particular example, I'm going to show actually how I'd expose this particular URL which you've just seen, and then I'd ask the analysts to go in and actually start using it. And part of this kind of example was to say, well, actually, how about I have a look now at what the users are actually doing. So part of that was to kind of visualize the usage patterns and what browsers are using, what pages are being requested, by what browser, and this could all help as far as my my transactional mix of what platform and what OS they're running. But also I can drill down to see exactly what those request responses were, and obviously I can pull those request responses out and do a whole lot of stuff with them. First of all, I can potentially model those from just importing them into a tool. So here's an example of a simple JSON request which has come through, and as you can see in there, there's browser type, how long it took to load the page, how long it took to render the page, and a whole stack of other information. So what I can do using a tool like Agile Requirements Designer is I can actually model that by importing that JSON file. So all I did was literally export what you've just seen as a simple JSON, and then look at importing that in. So what I've done is I've navigated to the output, which I've just renamed into a CSV file. And then what I'm doing is I'm actually splitting up that simple file into a format that I can understand. So in this case, this was just a number of different blocks that I could potentially do, which is the activities which people were doing, plus the data which was associated with them. So this is if someone clicked in enter name and there was different names embedded, that I could turn on that tracing and see all the different users that I've done there. Obviously, from a test data management perspective, what I'd be doing is I'd be looking at subsetting and masking that data, but keeping the integrity in place. But what I've done with this demo is kind of give you an example of how I can actually take the JSON from the DXA platform and actually then model it in my tool. And then what I can do is I can overlay the request response or the JSON request response to actually model that and regenerate all the possible paths that I could have. I could embed more data. I could, synthetically generate lots of different historical transactions. So, this is quite a powerful area if you're talking about adding modeling to your performance tests. And what I'm doing here, and this kind of, I did this on purpose in the sense of what we talked about with Copenhagen and the fact that we didn't have any of the GPX data. But the great thing was with this particular example, I was sat in our Ditton Park office, which is just near Slough. And because the mobile phone that I'm using was capturing my GPX data, that actually I could zoom down to where our offices are based, and actually see the location where that request came from. So I could actually take that GPX information and embed it to actually allow me to create the deltas as discussed on that previous example. So it's gives you a bit of context. This is obviously within our DXA platform, but this could be Splunk or it could be App Dynamics. Really what we're talking about is taking and learning from what's in production and using that as a model to give us kind of weightings and probability and goal based to understand what are our actual users doing. So I think we've set out the kind of the future vision of where next really, and I've talked about big data and analytics, and I've talked a bit about machine learning and and visualization and virtualization technologies, and I think all these systems are incredibly important. And actually I'm just getting a Skype message from Wilson Mark, because he's just contacted me about doing this with Introscope and trying to capture on and the logging information, so that way he can deep dive that from a profiler, a Java profiling perspective, and also from a to be able to understand what's happening. So part of it is Wilson's obviously speaking at this event. So it just gives you an idea that you've got to utilize different platforms. It could be the CA stack, it could be the HP stack, it could be the IBM stack. But part of it is this approach to the life cycle that is really important. And also that I mentioned about the life cycle app virtualization area is the reuse aspect, is leveraging the tools in development and the security tools and accessing the mainframe tools and dealing with API management tools to be able to get the information that you need to create those and architect those performance engineering scenarios. But I think there's also there's an area where I think we might be looking into in the future. I mentioned about Jarvis and how we're using that from our operational tools. I definitely see the potential around how you can take data sets based on historical transactions and potentially look at, based on what's happened before, what do we think is going to happen in the future. And also part of that filling in the gaps, and this happens quite a lot when you're maybe doing a SOAP test and you run out of data or maybe the login or LDAP goes down and you have a spike where there's no activity, and then you kind of throwing away that run because if it's not accurate. Maybe you can use the machine learning to do the segmentation and deal with those areas where potentially things have gone wrong and you don't want to have to redo them all. So I think there's definitely some opportunities around machine learning in the performance engineering space. And I'll go back to the kind of the book on digital experiences for a second. But I set this the example at the start around some of the kind of the challenges which I've been involved with in some of these components, and some of these are definitely coming faster than we probably want them to, and things like autonomous vehicles on the right hand side on the connected cars is an example of the Car2X capabilities and infrastructure to X. You've got to be able to scale that to millions of devices, and that's a performance issue. And when I've spoken to people about this before, and we talk about dealing with smart cities, I spoke to Chris Ambler about who was the head of Microsoft Gaming and EA Gaming, and talked about using gaming engines to understand what those environments might be like. I think things are going to get incredibly more complex, right? The complex event processing and those city data exchange, which I showed you a little bit there with the Copenhagen example. We've got the connected home stuff, which I think most of you here will be familiar with. The fact that Google Home and Alexa are kind of commonplace now. Those devices capabilities are increasing
day by day, and they're integrating with your cars and everything else. So then you're starting to see this kind of smart advisors and putting on the data brokerage platforms on top of that. I think combining that with the traits at the bottom, so the machine deep learning, artificial intelligence, neural nets, quantum fog computing, that kind of stuff's really going to really unlock a whole new capability, but it's also going to be huge challenges for us within the performance in space. So where next? I guess I mentioned the book. I'd recommend having a look at that. And there's also this free book on digital assurance, which I was part of with Paul Gerard, and that talks about drones and IoT and smart cities and how you can deal with these kind of challenges. And that's a free ebook to be able to download and request if you're interested in finding out some more information. Of course, you can contact me as well. My details are linkedin.com/in/automation. So it's probably the easiest one to remember. Feel free to reach out to me if you've got any kind of questions around or you need any guidance of where to look